This demo will cover how to use ANSYS Multizone in ICEM CFD on a simple multibody part. So here's the model in ICEM CFD. Let's display the surfaces and solid wire view. You can see the model. You can also see here's the large cylinder and the small cylinder. So to use Multizone, there's a few prerequisites. First of all, the model has to be properly connected. So we can check connection by right-clicking here, showing wide curves and showing them with their color by count. In ICEM CFD, red curves are double-edged curves where two surfaces meet, and blue are where three meet. So you can see here that the model is properly connected. The next thing is to set sizes. So if we go to the Mesh tab, you can see here there's a Part Mesh Setup option that lets us quickly set all the sizes. I'm just going to go with the default size of 1. And then if we want to, we can drill down and set specific sizes on individual parts. For instance, on the holes, we'll set 0.5 with a height off the wall of 0.1, a ratio of 1.2, and a number of layers, we'll just say 3. Apply. You can check these sizes through here. Those sorts of things are regular ICEM CFD hexa type functionality. In ICEM CFD, Multizone is a two-step process that allows flexibility in between. We start by going to the Blocking tab, create block. The default part name is going to be called Solid in this case. You can change that or we can go with it. Let's stretch this window up. But I'm going to use the 2D surface blocking. This is the first half of Multizone. You can select the surfaces that you want to include, or if you don't select them, it'll select everything. And then the method. So we're going to go with swept. Swept does a little more work in terms of finding out the multiple source and target, multiple direction, and projecting edges to complete all of that. For the free face mesh type, since some of these faces won't be able to be mapped, the remaining ones will be free. So what mesh type would you like on the free faces? We could go with all tri or quad dominant, etc. And then what method do you want to use? There's the ICEM CFD quad method, which uses a recursive loop algorithm, or there's the gambit pave method. Let's go with the gambit pave method. In more complicated models, you might have to set up which surfaces get swept, but in this case, it's smart enough to figure it out, and we'll just leave that blank. There's also other things you can do with merging blocks across dormant curves and so on, but we'll leave those settings alone. And we're going to initialize with settings, meaning take those sizes that we set earlier and use them. Then I hit apply. It takes a couple seconds, and you can see now that we've got an ICEM CFD hexa blocking here. Let's turn off the surfaces so you can see it. So this is a blocking. If you look at the expand the blocking branch and look at edges, you can display bunching. You can see that the bunching has been set up. You can also turn on the pre-mesh and see the initial surface mesh. We'll display that in solid wire. All right, now ICEM users are used to seeing the mesh in straight line format like this. So what you can see here is that it's paved some of these surfaces using the gambit algorithm. The side surfaces are mapped, and you can also see projection from this larger hole on this side, ending up projecting all the way through here. And that's going to help later when we try to sweep through this multiple source and target sweep model. What you don't have here is an actual volume mesh. This is just the surface mesh. So between the surface mesh and the volume mesh, you can come in and adjust things. So let's take a look at some of our pre-mesh. For instance, you might want to come up here and say that you need higher node count on these edges. So we could go in, we could select. You can select any one of these edges. You can say that you want, say, 7 nodes instead of 5. And we can copy that distribution to selected edges so that we copy it to its neighbors. Let's make these lines a little easier to see. Other things you can do include changing the face type. So I could go to change block and select a specific face to be free if it was mapped or vice versa. Or I can change the free face mesh type. And so in this case, let's change this to an all tri mesh. And for this surface here. And apply. Alright, so you can do these sorts of things. You can also change that later at this when it's a solid. You can add splits, remove splits, move things around, do all kinds of interesting things. So then after you've made these changes, the next step is to convert the 2D surface blocking into an actual true 3D blocking. So go back to the Blocking tab, Create Block, and we use this option here for 2D to 3D. So what this does is going to take those surface blocks and fill in toward the volume. So I'm going to create an ogre around faces, and I'm going to create an O-grid around these particular faces. So if I click here to say select parts, you can see holes is already checkmarked. That's because it saw that I'd set up an initial height and a ratio and a number of layers. So it automatically flagged it. I could add or remove as necessary. In this case, it's perfectly correct, so I'll just say accept. It calculates an offset distance based on that initial height, number of layers, and growth ratio. I can accept that or I can change it. And then finally, I select the fill method. I can pick simple, which just fills the whole volume with an unstructured fill type. Swept will do the multiple source and target sweep. And advanced will try to map blocks, and it'll subdivide the volume and do all kinds of interesting things for you. In this case, I'm going to swept. You can see the blockings appeared there already, but the mesh is out of date, so recompute. And I can see my boundary. If you're not used to these edges, let's just turn them off so you can get an idea of the mesh that was generated. The surface tries on this side went away because it was mapped from quads on this side. You can see here the multiple source and target sweeping. Let's display the cut planes. We'll turn off the pre-mesh. And you can see here's the cut plane. You can roll it through the volume, switch to middle X plane, and view this. And you can see that the mesh is conformal because it was a multi-body part. You can see the cut plane through there and the boundary layers and things like that. At the moment, this is actually a pre-mesh. If you want to export an actual mesh, you have to right-click on pre-mesh and convert to unstructured mesh. This is an actual mesh with nodes and elements that you can export to most solvers. You can also look at the cut plane for this mesh, and we can turn on the volume elements there, and you can see that. Mesh can be exported via the output menu, or you could apply constraints and loads and solve it through this menu here where you would pick your solvers. All different ways to use ICEM CFD. If you have any questions, please contact us. Thank you.